Okay, so today we're on unit 5.6b, okay, and we're going to be doing a lot of what we did yesterday. So we're still solving angle relationships, okay, and yesterday we looked at vertical angle relationships, corresponding angles, and same side interior. Okay, today we're going to look at two new ones. Okay, so you're still going to have pretty much the same setup, so still two parallel lines with a transversal that's going through them. Okay, but the first one I want to look at is if we had this angle and this angle. Okay, if I was looking at those two angles, what would we call that angle relationship? Anyone know? Are these same side or alternate? Alternate, because they're on different sides of the transversal. So alternate. We know they're alternate. And are they interior or exterior? Exterior, because they're both outside of the parallel lines. So alternate exterior angles. Okay, so let's see if we can kind of like discover this relationship, okay? If I asked you, where would the vertical angle for this one be? Where would you put it? Right here, so just opposite of it? Okay, so would you agree that these two are equal to each other because of vertical angles? What would these two be called? Corresponding. And what do you know about corresponding angles? They are also equal, okay? So by default, by definition, alternate exterior angles are also equal to each other. So set equal to each other and solve. Set equal to each other and solve. Okay, so alternate exterior angles, you're going to set the two parts equal to each other and solve. The other type of relationship that you're going to look at is, again, if we have two parallel lines. Those are supposed to be parallel. Sorry, they're a little wonky. Okay, and I tell you for this one that it is this angle and this angle. So those two angles. How would you label that kind of relationship? What would that be called? These are alternate, okay? So we know that it's going to be alternate. And they are both interior. They're inside the parallel lines. So alternate interior angles. Okay, alternate interior angles. So let's see if we can kind of discover this relationship. Where would the vertical angle to this one be? Straight across from it, so it would be right here. Okay, those would be congruent, and congruent means same measure. And then these two would be what? Corresponding, and corresponding also means the same measure. So by default, we just figured out, we proved that alternate interior angles are what? Equal to each other, right? So again, you're going to set them equal to each other and solve. Set equal to each other and solve. Okay, so those are going to be the two different ones that we're looking at today. Anyone have any questions about why they're called what they're called, or that one kind of semi-basic? Okay, let's try for example number 1. And for all of these, we're looking to solve for x, and I want you to find the missing angle measurement, okay? You guys are taking a quiz on Friday. I want you to be really careful when you take that quiz and when you take your test next week to read the question, okay? Sometimes I'm just asking you for what's the measure of x. Sometimes I'm asking you, for the whole angle, okay? Especially on a multiple choice question, I almost guarantee both answers would be there. So please make sure that you're reading the questions kind of carefully so you don't goof them up, okay? If I ask you to solve, for example number 1, I give you two parallel lines with a transversal going through them. Two parallel lines with a transversal going through them. Okay, and I tell you that, let's say this one up here is 3x, and right here is 120 degrees. So 3x degrees, sorry, and 120 degrees. Now, I also want you to make sure that you know what they're called in relationship to each other, okay? Even if everything you're doing today, all the problems, you're going to end up setting them equal to each other. But I want you to make sure you know what they're called, because on a couple of questions on your test, it's asking you, why do you know that? Okay, and you know that to set them equal because they are what they're called. So what would you call this one? These are alternate because they're on different sides of the transversal, and interior because they're in between the parallels. Okay, so these are alternate interior angles. And how do you solve for alternate interior angles? Set them equal to each other. So 3x is equal to 120 degrees. To get x by itself, you divide both sides by 3. So that tells you that x is equal to 40 degrees. That's the first part. X is equal to 40 degrees. How do I find this missing angle? Plug it in. Okay, if you plug that in, we're going to do 3 times 40 degrees. And 3 times 40 degrees equals what? 120 degrees. And does that make sense? That both of these are 120? Yeah, because they're supposed to be. They're supposed to be set equal to each other. So they're supposed to be the same answer. Okay? Questions on how I did that? Not too bad, hopefully. Okay, let's try another one. Number 2. Okay, for number 2. If I have, let's say we have up and down parallels. Okay, so up and down parallels with a transversal going through like this.
We can't see.
Oh, sorry. Thank you. Okay, up and down parallels with a transversal going through them. And I tell you that this measurement is 60 degrees. And this measurement is 2x plus 4 degrees. 60 degrees and 2x plus 4 degrees. What type of angle relationship do these have? These are alternate because they're on different sides. And are they interior or exterior? Interior because they're in between the parallels, so alternate interior angles. We just determined that you do what to solve alternate interior angles? Set them equal to each other. So 60 is equal to 2x plus 4. Start undoing that. So we're going to move the 4. So subtract 4 from both sides. So subtract 4, we got 56 is equal to 2x. To get x by itself, divide that 2 away. So if you divide both sides by 2, it's 56 divided by 2.
28.
28? So you're missing, or your x is equal to 28 degrees. Now, how do you solve for this missing angle? Plug it in. Okay, remember, anytime you plug something in, you have to put it in parentheses. So 2 multiplied by 28 plus 4, what is 2 times 28? 56. And 56 plus 4 is 60 degrees. So the missing measurement is 60 degrees. Is this confusing? Is this easy? Does this make you sleepy? A little bit? Sorry. Okay, 2 more and then we'll be done. I'm sorry to bore you. If it's easy, I'm hoping that's a good thing. If you're bored, hopefully that's because it's easy. And I'm okay with that. Okay, next one, same thing. I'd like you to solve for x and find the missing angle measurement. Okay, for number 3, let's try, again, 2 parallel lines with a transversal that goes through them. Okay, here, if I give you 3y plus 53 degrees and 7y minus 55 degrees. 3y plus 53 degrees and 7y minus 55 degrees. What would you call this angle measure or angle relationship? Alternate, because they're one on both sides of the transversal, so one on the left, one on the right. Exterior, because they're outside the parallel lines, so alternate exterior angles. And alternate exterior angles, how do we solve them? Set them equal to each other, so 3y plus 53 is equal to 7y minus 55. What would you want to move first here? Do you want to move the numbers or the letters?
The letters.
The letters, okay. Which one would you move, the 3y or the 7y?
3y.
I'd go 3y because it's going to make it so you don't have to deal with negatives. Okay, so 53 equals 7y minus 3y is 4y minus 55. Then add 55 to both sides to get that moved over. You add those together. That's 108 is equal to 4y. Let's get y by itself. Divide both sides by 4. If you divide both sides by 4, what's 108 divided by 4? 27. Right, now, did it matter that I was solving for y instead of x? No. You're still solving for the variable. Okay, doesn't matter what letter you're solving for, same process. Okay, so 27 is equal to y. How would you solve? Plug in, okay? Would you prefer to plug in for the 3y or the 7y?
3y.
You're going to do 3? Okay. Does not really matter. You should get the same answer. Okay, so you're going to do 27 times 3. Do it on the side of your paper if you need to. Okay, so if you borrow and carry 81, are we okay with that? Yeah? So 3 times 27 plus 53. 3 times 27 was equal to 81 plus 53. And what's 81 plus 53? 134 degrees. Okay, did anyone do the 7y minus 55? Do I need to plug that in? No, why? Because they're going to be the same. Okay, you could plug it in to check your answer, but they will be the same. Should be the same. Okay, let's do one more and then we'll be all done. And I'll give you guys some time to work and hopefully not have any homework. Last one. Let's go 2 parallel lines up and down with a transversal going through. If I tell you that outside here, so on the left is 3x minus 2 degrees, and here is x plus 78 degrees. 3x minus 2 degrees and x plus 78 degrees. See if we can at least start this on your own. What type of angle relationship are these? Alternate, because it's one side. One is on the top of the transversal, one's below it. And exterior, because they're outside the parallels. So alternate exterior angles. Alternate exterior angles you can set equal to each other. So 3x minus 2 is equal to x plus 78. Start by moving the 1x, so subtract 1x from both sides. Subtract 1x, 3x minus 1x is 2x. Minus 2 is equal to 78. Inverse operation, so add 2 to both sides. 2x will equal 80. And then to get x by itself, divide both sides by 2. So we get an x value of 40. Then last step is to plug something in. So if we plug in here, that would give you 40 plus 78. And what is 40 plus 78? 118. Okay, so your missing angle measurements are 118 degrees. Questions on how we did that? Okay, so homework is going to be, or work, because you guys will probably be able to finish it in class. Homework is going to be worksheet 5.6B. Okay, if you have, and you're doing numbers 1 through 12, so you're doing the whole thing. Okay, if you have any late assignments that you need to turn in to me, feel free to bring them